Good morning. So with the virtual day, we just need to finish up the notes from last time, as well as do 4.3 and 4.4 today. So we're just going to go ahead and jump right in. So on this one, I just wanted to kind of go over this one again. We rushed through it in class, and I just kind of wanted to start over. So with this, there are actually two options here. So option one is to convert to degrees. Okay. So if we were to convert this to degrees, we would have 13 pi over 12, multiply it by 180 over pi, and this would come out as 195 degrees. And then, so we could do it as, so now it's the cosine of 195, and we could, of course, do that the same way we had been doing the ones on the last page. We could treat this as like cosine of 135 plus 60, because those are both on the unit circle, and you could do it that way. And I'm not going to go over that way again. You can look back at the last page to see how to do this, but this is an option for you. Okay. There is also the option that it suggests right here with adding or subtracting pi fourths. So, for example, we need to turn 13 pi 12ths into something we can work with a little bit more. So if we take 13 pi over 12 and we subtract pi fourths, well, pi fourths is really 3 pi 12ths. And that would give us 10 pi over 12 or 5 pi over 6, which of course is on the unit circle, so that's really helpful. So then we would actually say that this is, so here's our other option. This is the cosine of, and we would use the 5 pi over 6, and we would add the pi fourths, and this would be equivalent. So the reason that that's equivalent is because if we take 5/6 and we work backwards, if we take 5 pi 6 and add this back in, we would get here. Okay, so these two together make this one, because this one minus this one gave us this one. I hope that makes sense to you guys. So then we follow the same pattern here. So then we create this one as alpha, this one is beta, and we can say that the cosine of 5 pi over 6 times by the cosine of pi fourths, and it's cosine, so this is going to be minus here, the sine of 5 pi 6 times by the sine of pi fourths. Okay, and then we just go ahead and do it. We use our unit circle to get these values. So the cosine of 5 pi over 6 is the negative square root of 3 over 2. Cosine of pi fourths is root 2 over 2. Minus sine of 5 pi 6 would be 1/2. And the sine of pi fourths is root 2 over 2. So then this comes out to be negative square root of 6 over 4 minus square root of 2 over 4. So this ends up being negative square roots of 2 minus square roots of 6, all divided by 4. Okay. And I do want you guys to think about whether or not these should be negative or positive. What quadrant are we working in here? So if we're at 13 pi over 12, that puts us right about there in quadrant 3. So tangent is the only thing that should be positive. So cosine being negative makes sense. Okay, and I did want to talk to you guys about, okay, but what if I had asked for the secant of 13 pi over 12? How do I get that? Well, it's just the reciprocal, right? It would just be 4 over negative square roots of 2 minus square roots of 6. The reason I bring this one in particular up, you guys do not need to rationalize the denominator of these. It gets to a point where rationalizing it doesn't really make it any simpler, and this is that point. So you are okay to just leave it the way that it appears. You do not need to rationalize. Okay, so I'm going to do one more example with the tangent here. But we are going to skip this cosecant. Good morning, Logan. Can you go find your daddy, please? Go find Dad. So the tangent of 11 pi over 12 then, we're going to do the same thing. This time, rather than subtracting pi fourths like we did before, I'm actually going to show you guys what happens if you add pi fourths instead. And so again, this would be actually 3 pi over 12. When we add them, we get 14 pi over 12, which of course is just 7 pi 6, which is also on the unit circle. So this one, instead, we're actually going to have the tangent of, and this time we're actually going to have 7 pi over 6 minus pi fourths. Okay, and I just did it this way because I wanted to make sure you guys had seen both ways. Okay, just a minute, Logan. So, from this one, then, we know that the formula tells us that this one's alpha and this one's beta. So we are going to do the tangent of 7 pi over 6. And we were minus here, so we're going to be minus here, minus the tangent of pi fourths, all divided by, this one's going to be 1, it was all minus, so this one's plus, and then we're going to multiply them together, the tangent of 7 pi over 6.
Yes.
Times by the tangent, Logan,
Logan,
I need you to go find your dad. So then we can go ahead and work through this. The tangent of 7 pi over 6 is root 3 over 3. The tangent of pi fourths is 1. And then we've got the tangent of 7 pi over 6, which is root 3 over 3. So then we do 1 plus root 3 over 3 times by 1. And we get root 3 over 3 minus 1 over 1 plus root 3 over 3. Now, I'm fine with you not rationalizing, but I would like to see you guys actually come in and simplify this a little bit. So this is 3 over 3. This is also 3 over 3. So this one would equal root 3 minus 3 all over 3. And this one would be root 3 plus 3 all over 3. And then we would keep change flip. And for the record, you should always put the radical second. That's just a standard form thing. So just for the record. So we're going to keep change flip it. These, of course, cancel. So you actually end up with negative 3 plus root 3 over 3 plus the square root of 3. Okay. And there you go. Okay. So for the next couple examples, we need to be paying attention to a couple of things with where our quadrants are. So I'm going to go ahead and pause here, and I will be right back to finish that up. Okay, sorry about the little pause there. Let's go ahead and jump into this one. So we have to, when we're given problems like this, we have to kind of really consider what information it's giving us. So if they're giving us that the cosecant of alpha is 3, remember that that's really giving us that the 1 over sine of alpha is equal to 1/3. And then it's also giving us this piece of information that we are looking in the first quadrant. Okay, so I'm going to draw this picture out for you guys over here. So here's our little first quadrant. So the triangle that we are working with here, here's your right angle, here's your angle that you're working with, so we'll call it alpha. And what it's telling us is that sine is 1 over 3, so that would mean that this is 1 and this is 3. So we do still need our x value here. Okay, so this would be x squared is going to equal 3 squared minus 1 squared. So x squared is 8, and x is, you could say the square root of 8. I'm going to say 2 square roots of 2. Okay, 8 is 4 and 2, right? Split that one up. These ones get out. Okay, so x equals 2 root 2. So now that we have that, we can do a little bit more. But let's look at the other one first. So remember that this is important, but not necessarily what it's asking you for. Okay, so now we have to go down and figure out the other piece of what it's telling us. And this one is actually going to be in the second quadrant. So we're going to be on this other side here. So here's your triangle that we're working with. There's your right angle. This is our beta. And this one is telling us that beta is in quadrant 2, and it's telling us that the tangent is -7. So keep in mind that in order for tangent to be negative, either sine or cosine has to be negative, but not both. Okay, so if tangent is negative, that means either this one's negative or this one's negative, but not both. Now, if you actually look at it, it's pretty obvious that the y is positive and that the x is what would be negative. Okay, so -7/1, but it's actually 7 over -1. Okay, and then we can find the hypotenuse of this one pretty easily too. So we would just say that, we'll call it c. C squared equals 7 squared plus -1 squared. So c squared equals the square root of 50. And again, I'm always going to, sorry, that's not true. C squared equals 50 and c equals the square root of 50. But I'm always going to go another step and say that this is actually 5 square roots of 2 because 50 can be broken up into 25 and 2. 25 is 5 squared. Okay. That's mostly just a personal habit, and I just think it makes everything simpler, so I'm always going to do that. So then, when we're dealing with cosine of this, what it's asking us to do, so it's saying cosine of, switch some colors here, sorry. Cosine of alpha, oops, wrong one here. Cosine of alpha plus beta, right? But we're talking about these ones specifically. So this would be equivalent to the cosine of alpha multiplied by the cosine of beta minus, it was plus, so we're going to turn into minus, the sine of alpha multiplied by the sine of beta. Now, you don't necessarily have to write that out every time, okay? But I wanted to make sure that you have it right here so I don't have to flip back and forth for you guys. So then, from here, it's just a matter of plugging in these values that we know. If we're looking at alpha, the cosine would be at the adjacent side over the hypotenuse. Well, we know that the adjacent side is 2 root 2. So we would say this is 2 root 2 over the hypotenuse of 3. The cosine of beta would be down here, and it would be -1 over our hypotenuse, which we found to be 5 root 2. Subtract. Now our sine of alpha, it actually already gave us, that's 1/3. And then the sine of beta would be opposite over hypotenuse, so 7 over those 5 square roots of 2. And then we simplify this. Now I'm going to slide these over so we have just a little bit more room to work here. So this would equal -2 square roots of 2 over 15 square roots of 2. So remember, outsides can interact and insides can interact, but they cannot interact with each other. So the 3 and the 5 can multiply because they're both outside of the radical, but the square root of 2 cannot interact with that. Same here, the -1 and the 2 can interact, the square root of 2 cannot. So this would be minus 7 over also 15 square roots of 2, which is very convenient because we have a common denominator. So -7 minus 2 square roots of 2 over 15 square roots of 2. And as I said in the last video, you do not need to rationalize your denominator. You can leave it just like that. Okay. Now, if it were to ask us for sine, this would be the sine of alpha multiplied by the cosine of beta. It was plus, and we're dealing with sine, so it'll be plus the sine of beta multiplied by the cosine of alpha. Now we already have these values, okay? So the sine of alpha is 1/3. The cosine of beta is -1 over 5 square roots of 2. The sine of beta was 7 over 5 square roots of 2. And the cosine of alpha was 2 square roots of 2 over 3. And then we simplify this. So that's -1 over 15 square roots of 2 plus 14 square roots of 2 over 15 square roots of 2. Again, we have a common denominator already, which is useful. So we're going to get -1 plus 14 square roots of 2 over 15 square roots of 2. Okay. Next thing it asks us for is tangent. And you could use the formula. I gave you a formula for tangent right here. And you're welcome to use that. However, we also know that tangent is equivalent to sine over cosine of whatever's inside there. So we could say that this is equivalent to the sine of alpha plus beta divided by the cosine of alpha plus beta. We already have these two values. We already know that the sine is -1 plus 14 square roots of 2 over 15 square roots of 2. And cosine is -7 minus 2 square roots of 2 over 15 square roots of 2. We can keep change flip this, so -1 plus 14 root 2 over 15 root 2 multiplied, that was really messy, I'm going to rewrite that. -1 plus 14 square roots of 2 over 15 square roots of 2 multiplied by, we're going to flip this one upside down, so 15 square roots of 2 is on top, and -7 minus 2 root 2 is on the bottom. Now, of course, these just cancel, which is very convenient. And we get -1 plus 14 square roots of 2 divided by -7 minus 2 square roots of 2. There you have it. There's your tangent. Okay. Now, if they asked you to do the cosine with the subtraction, remember it would just change some signs. So this one would be, and I'm going to go straight to these because we already have these, right? So instead of being a minus in the middle, it's just going to be a plus, but it's going to be the exact same numbers. So I'm just going to copy this down. And all I'm going to have to do here then is change this to a plus. And again, we already have all these values. So -2 square roots of 2 over 15 root 2 plus 7 over 15 root 2. Okay. So then we're just going to get 7 minus 2 square roots of 2 over 15 root 2. So it really only changes the sign in front of that 7. Okay. And then secant, of course, is 1 over the cosine of this. Well, that's right there. So 1 over all of that is just the reciprocal of it, right? So this one ends up being 15 root 2 over 7 minus 2 root 2. Like I said, you don't need to worry about rationalizing the denominator at this point. Okay, there you have it. Okay, we are going to do a story problem because this one's weird. So for a climbing wall, a guy wire R is attached 47 feet height on the vertical pole. Okay, so here's the vertical pole. And then the guy wire it's talking about is right here. Okay, and then another one is also attached. So we've got one here and then we've got one here that get attached to this pole. Okay, we know that this is 50 feet away. And we know that beta is this big angle and the alpha is this little baby angle. Now I need you to notice that the triangle that contains alpha is not a right triangle. Okay, so that's why this one's a little bit different than the ones we've done in the past. So I'm going to talk about this angle for a second because we do have a lot of information about this triangle. This triangle that would be right here, we actually do have a lot of information about. We know this is 50, we know this is 40, this is S, right? But we don't know a whole lot about this angle. So I'm just going to name this angle something just for the ease of talking about it. So I'm going to call this angle x. Okay. Now what it wants me to find is the tangent of alpha. Okay. So that means I need to be able to do something with the tangent. I need to be able to do something with alpha. I need to know something about alpha. But I can't say, oh, it's just opposite over adjacent, because this isn't a right triangle. So we need to find a different way around this. So what we do is we define alpha to be a little bit more specific. Now alpha is beta minus this x value. Okay, so I'm going to call it beta minus x, because that's what alpha would be. So then instead of asking for the tangent of alpha, really they're asking for the tangent of beta minus x. Well, we know how to find these. And these are both right triangles, so we do know some values of those. So instead of using beta and alpha here, we would say this is equal to the tangent of beta minus the tangent of x divided by 1 plus the tangent of beta multiplied by the tangent of x. Well, could we find the tangent of beta? Well, that's this triangle. It would be opposite over adjacent. That's this big triangle, so that's 47 over 50. So sure, of course we can find beta, right? So I'm going to make beta be blue here, and we'll keep x as the purple. Okay, so I'm just going to change some colors just so it's a little bit easier to see what we're doing here, which triangle we're talking about. So beta, I'm going to go ahead and write it in here. So the triangle that's dealing with beta is from here over to here, and then this bigger one. Okay? So opposite over adjacent for tangent would be 47 over 50. So then this is 47 over 50 minus, now we need to do tangent of x. So I'm going to change the color here just to make it a little bit more clear what we're talking about. And I will also do the same thing. So x, we're dealing with this smaller triangle right here. Okay. So the tangent for it, oh my goodness, would be only 40 over 50. And then we would divide it and do 1 plus, and again, we found these values, so now we just have to plug them into the correct place in the formula. Now, these have a common denominator, so this is really 7 over 50. We can go ahead and combine those. They already have a common denominator. Now, this one's a little bit trickier to do without a calculator, so I'm going to go ahead and pull up my calculator. And I'll go ahead and put these both up. Okay, so we've got 47 over 50 multiplied by 40 over 50. Turn it back into a fraction for me here. So this is 1 plus 94 over 125. Now I think it's easier if you deal with this first and get this into a format that's a little bit more friendly. So this is really 125 over 125. So that's actually 7 over 50 over 219 over 125. And you could just put this in your calculator at this point. I'm just going to keep doing it by hand out of habit more than anything. So keep, change, flip. So 7 times 125 gives us 875. And 50 times by 219 gives us 10,950. Gives us 35 over 438. And I do think it wants it rounded to 2 decimal places. So I guess I do actually want that in decimal form. So that's actually going to be 0.08. The tangent of alpha is 0.08. Okay, so there you have it. So there we go. That's how you would use it in this type of story problem. I hope that makes sense. Please let me know if you have questions on that, because that one's a little bit strange. Okay, so we're going to jump right into cofunctions now. So I want you guys to take a look at this. You know what? I do want that up still, actually. Sorry, just one second. Let me get the calculator back up. Okay. So based on this triangle to the left, we know that if we are looking at this angle, the 53.13, what would be 8 over 10? Well, that's the opposite side over the hypotenuse. So this would be the sine. The sine of 53.13 is 8 over 10. Okay, that is true. We can also find out what this angle is in this triangle, though. What would this angle be? Well, there's two ways you can think about this. You can do 180 minus 90 minus the 53.13 that we know we have, and get that it's 36.87. You can also think about this like, well, this is 90, which means these two have to be 90. So you could actually just go straight to 90 minus 53.13. Should end up in the same spot. Sure enough. Okay. But that means that for this one, this is actually the adjacent side and the hypotenuse. So we're actually saying that the cosine of 36.87 is also 8 out of 10. So you see how these are kind of, they're the same value, but they're kind of the opposite sine cosine, right? So we know that the cosine of pi thirds is 1/2. We know that from the unit circle. Okay. What that also means is that the sine of pi over 6 is also 1/2. So let me explain why. If we have a triangle, and in that triangle we know we have a 90-degree angle, and we know that this one is pi thirds. Okay. Well, if we're in the unit circle, this is 1, this is 2. Oh, nope, sorry. This is 1, and this is 2, because it's adjacent over opposite, right? And this one, we could figure out pretty easily, but we don't even need to. Because if this side is pi thirds, what's left over for this? Well, the whole triangle needs to add up to pi. This one takes up pi halves, so that leaves us with pi halves, of course. And then if we subtract that pi thirds that we've already used up, and you can do this by hand or not, I really don't care. So I'm going to go ahead and turn it into over 6. So 3 pi over 6 and 2 pi over 6, which of course leaves us with 1 pi over 6. So this angle is 1 pi over 6. Well, this is its opposite side, and this is its hypotenuse. So it is also 1/2. And I got the pi 6 by just thinking about what angles in a triangle would have to be, right? These are complementary angles. They need to be complementary so that all three can be supplementary. Okay, I hope that makes sense. So here's the big idea. This is why this matters. Okay, if you already have pi halves taken up by the right angle, then the angle that's left over is pi halves minus the other angle, right? So this one is already pi halves. That pi halves is already gone. These two together can give us pi halves. And if we know that this one's theta, pi halves minus theta would give us this one. Okay? And what this is stating, what these are stating, is that the sine of one of those angles is equal to the cosine of the opposite one. Or vice versa. The cosine of one of them is equal to the sine of the other. Okay? And that's all about the opposite and adjacent, right? Because if you're talking about this purple one, this is opposite, hypotenuse, adjacent. But if you're talking about the orange one, then this is opposite, this is adjacent, and this is hypotenuse. So because these two switch in these cases, when you're looking at this one and you're looking at opposite, you're looking at this side length. But when you're looking at this one's opposite, you're looking at this side length. So if we are looking at a side specifically rather than the angle, if we look at this side in relation to these angles, this side is opposite of this one, but adjacent to this one. And then the hypotenuse is the same in both. So because of that, it kind of flips these two things around on it. Okay, that's all it's saying. So it wants us to verify this identity, and it is an important identity, so we'll go ahead and do it. We know, so it's asking us to verify that the cosine of theta minus pi is equal to the negative cosine of theta. So we know that if this is the cosine, well, that's a difference. So we can say the cosine of theta multiplied by the cosine of pi plus, because it was minus, so we're going to switch to plus, the sine of theta multiplied by the sine of pi. Now, we have no idea what theta is. So that one honestly gets kind of stuck. There's not a whole lot we can do with that. That's just cosine of theta, whatever it is. But we do know the cosine of pi. If we look at our unit circle at pi, cosine is at -1. Same thing here. We really don't know what the sine of theta is because we don't know what theta is. But we do know that the sine at pi is 0. So then this would be the cosine of theta multiplied by -1 really just brings this negative out in front, right? You could put the 1 there if you want, but it's unnecessary. Plus 0. Well, the negative cosine of theta is definitely equal to the negative cosine of theta. So there we have it. These are indeed true. We can check it off. That's what we wanted to get to. Okay, so that does it for the end of what we were supposed to get to last time. And then I'm going to post another video that has today's material for you. Please let me know what questions you have.